Ground floor, end of terraced and mid-terraced apartments are very difficult dwellings to make compliant with Part L1A. Input the details of the project. We will use the full fill method of construction. It is an apartment, no flat roof, and the insulation is above the floor slab. Usually apartments have intermediate concrete floor slabs. ACDs are no longer sufficient if the new fee standard is to be achieved. We need to use the robust or enhanced details. It is an apartment, end of terraced, and the dwelling is a ground floor apartment. As you can see, there are a lot of construction joints and exposed areas with ground floor apartments, and this makes design compliance difficult to achieve. This project has 2 exposed elevations, and there's a small volume with these apartments. Compliance is also made difficult by contemporary apartment design, which has a lot of glass and can cause overheating. We have collected the dimensions required by SAP and the thermal bridge calculator. Let's design the Part L1A specification. Before we start into the design process, let us look at the thermal bridge. As you can see, it is over 0.1. Even though we have used enhanced details, this is because of the length of the construction joints and exposed areas with ground floor apartments. The recommended Y factor when designing to the 2013 regulations is 0.05. Let's go back to the first part of the specification to be designed the floor. When designing a Part L1A specification using the Foresight system, the user chooses a performance level to design to, in this case the 2013 regulations. The designer chooses the structural materials and insulation to use, and the software calculates the appropriate depths of the insulation material. The Foresight software knows that the recommended U values needed to achieve fee compliance is not enough in this particular case, so they will present a better U value to compensate for the bad Y factor. The 2013 design standard is chosen for the walls. The designer chooses the structural material and the insulation material to be used, and the software will present the appropriate depth of insulation needed to achieve compliance. The software will calculate the U value to be R433 and use this information in the calculation of the design EPC. Flat ceilings are not designed because this is a ground floor apartment. Same with sloping ceilings and the flat roof. The area is not to be designed or locked, and the designer simply clicks on save and is automatically moved to the next section to be designed. The windows. The designer chooses the 2013 standard. 2 choices will be presented. If there is a lot of glass, the user should choose a U value of 1 for the windows. If not, then 1.2 value for the windows should be taken. The doors and roof lights do not need to be designed. Thermal bridge, as you can see, is very high, and we have already discussed this earlier. Air permeability. The user chooses the 2013 standard, and the software will give 2 options with ground floor apartments. It's our advice that the designer chooses the 4 air exchanges. Anything less than this will require a heat recovery system. Heat recovery systems suitable for small dwellings are not common, and this is why apartments should not be designed to an extreme fabric standard. Again, this is something that the industry needs to look at. With the air tightness chosen, we can use natural ventilation. Lighting should always be 100% energy efficient. Stoves as secondary heating sources are not suitable for apartments, and a none option should be taken. Solar panels again are not suitable in apartment design, and a none option should be taken. Hot water storage. Combination boilers are most suited to apartment design and requires no storage tank. We are looking at the option of introducing a community heating system as an option, which we hope to introduce shortly. Water usage. A none option should be taken when designing an apartment. All our boilers have an efficiency of at least 90%. Heat control is now becoming a very important part of Part L1A design, and we are using delayed start thermostat and programmer. All the design decisions have been made. Now let's see if they are compliant with the 2013 regulations. As you can see, there is non-compliance in the DER and TIFI, so let's go back to the design process. When we look at the design options, we are very limited in what we can do. We cannot improve any element of the fixed building specification because secondary heating systems, stoves and solar and heat recovery systems are not suitable for apartment design. So we'll have to look at the fabric for design compliance. The most cost-effective way is to increase the performance of the wall. We'll increase the depth of the insulated boards to 85 mm. And because there's a lot of glass, we'll increase the performance of the windows to 0.08 U value. Yes, compliance with Part L1A has been achieved. From our experience, the fee standard is as high a performance that can be achieved with apartments and with the technology that is in common use at the moment. We do not offer an option for extreme fabric design because the low air exchanges needed for passive standard cannot be achieved in smaller dwellings because of heat recovery systems not being suitable. As you said before, ground floor apartments along with top floor apartments are now the most challenging dwellings to make compliant with Part L1A.